So let's do some examples. State any restrictions and reduce. That's the general instructions for both of these examples. So the first one is x squared minus y squared over 3x squared plus 3xy. I'm going to factor that as, so the top one is a difference of two squares, so it factors as the conjugate x minus y times x plus y. The bottom has a common factor of 3x, so I factor that out, and I get x plus y for my other factor. Now don't cancel the x plus y's yet, because you need to find your restrictions before you reduce, always. Even if they ask you to reduce it, and then part 2 says what are the restrictions, you have to go back to before you reduced to find the restrictions, okay? So the restrictions here, x can't be 0 and x cannot be negative y. That could also be written as y cannot be negative x. I'm not sure why I wrote it this way. Either way, it means the same thing. So that's those two restrictions. Then, after doing that, you can reduce the x plus y's because it's a factor in the numerator and it's a factor of the denominator. So I end up with x minus y over 3. Now notice in the formula x minus y over 3x. In the formula x minus y over 3x, obviously x can't be 0 there, but it's not obvious that x can't be negative y, because if I plug x equals negative y in there, I get negative 2y over negative 3y, which is 2/3. It looks perfectly fine. It's 2/3. But if I plug it into the original expression, it's easiest to see from the factored form. That's without these crossed off. If you put x equals minus y in here, you get 0 over 0, which is what we call indiscriminate. Indiscriminate is worse than undefined. In either case, you're dividing by 0. So that's why you can't have that, because it's the original that we're interested in the restrictions on. These two are actually not equivalent. They're equivalent except when x equals negative y. Then they're different there. This is undefined there. This is defined there. Okay? So always find the restrictions before you reduce. If you do that, you'll get a lot fewer of these wrong. Okay, example 2. X squared minus 9 over x squared plus 2x divided by x minus 3 over x plus 5. The first thing I did is I just factored the first fraction. The second fraction is already factored. So difference of two squares on top, common factor of x on the denominator, divided by, now I didn't do the reciprocal and multiply yet, and the reason is because I had to find the restrictions before I worry about simplifying anything, and that would be part of simplifying. Factoring isn't simplifying, it's just factoring. It's just writing it in a different form. It's not necessarily simpler, right? So I get x is not equal to 0 from here. X is not equal to negative 2 from here. Again, it's just you can't divide by 0. And x cannot equal negative 5 from here. If I flipped this upside down and multiplied without thinking about this, I would miss my restriction, x is not equal to negative 5. So you got to be careful of that. So then I multiply by the reciprocal of this. Think of that as a simplification of the problem, because you're multiplying instead of dividing, right? And now notice I have a new denominator, x minus 3, and that can't be 0 either. So x cannot equal 3. So the thing I'm dividing by, the rational expression I'm dividing by, neither the numerator nor the denominator can be 0 as it works out, because x plus 5 is the denominator at first, and then after you do the reciprocal, it's the numerator, and x minus 3 is the denominator, right? So I have these 4 restrictions, and then I reduce, and the only thing that reduces is the factor x minus 3 over x minus 3. Then just write it out without those factors, so it's nice and clean. You get x plus 3 times x plus 5 over x times x plus 2. And that's that.